Hey Calculus kids, it's Dr. Callahan with week 2 Monday. Congrats, you guys finished the first week. So we're now moving on to week number 2. So definitely I give you guys the opportunity to see your grades on Monday. I actually um, video recording this on a Friday, so your homework is actually not due until Sunday. So even though today I'm talking about Monday, but I don't really actually have your grades done yet, I'm going to do that over this weekend. So my suggestion is just wait till Tuesday and I'll have your grades updated by Tuesday's video. So just keep that in mind. All right, you guys. So these are the following 3 questions. Go ahead and pause the video and answer them. Okay, so let's go ahead and create your assignment for week 2 Monday. All right, so week 2 Monday, and this is calculus AB semester 2. Today our focus is going to be on practice problems with integration. In addition to that, we are also going to talk about definite integrals. I'll just put integration and definite integrals. Okay, apparently I can't put the last one there. That's okay though. So your instructions for today is to make sure you guys are watching the video. You need to check in with me on a daily basis. That's critically important for this class. Every day you have 45 minutes of this class, so your lessons are generally reserved for 45 minutes and they're planned for 45 minutes. Make sure you guys are uploading the assignments, especially with Math Excel and also the AP College Board. Make sure you guys are completing those. This is week 2, so your Math Excel is open for week 2. It's always due on the Sunday and it's due by 11:59 p.m. Even if you're doing it late, I will still give you partial credit for it, so don't just leave it blank as a 0. If you have any questions, please email me at this email address. Keep in mind your attendance is taken by you viewing the assignment, but your academic grade, which is grade that you need to pass the class with a 60% or better, is determined by you completing the Math Excel in addition to the AP College Board. And then, of course, if you're doing any assignments that you need to upload to the assignment itself, make sure you're doing that. There are 2 links that you need for this class. The first one is the YouTube channel. So after today, you guys should have 6 videos, 5 from week 1 and then 1 from today. And then also your Google Doc for your calculus, which has all the information that you need from your syllabus to the test correction templates, etc. If you do need hard copies, this is the last week that we have before I see you guys in person. I do have the first 9 weeks of the guided notes printed out for you guys. It's right here in the middle versus calculus in addition to your warm-up log. And this is your schedule. So your second period starts from 9:20 to 10:05, so 45 minutes. So make sure you guys are reserving that time, those 45 minutes for specifically for second period. So that way you can go do other things for your other class during the other rest of the day. All right, so then every day it's gonna give you 10 points. It's due by 3:30 p.m. And then of course, today is Monday, January 11th. So I'm gonna hit assign. All right, so if you don't have the hard copy and you have a printer at home and you would like to go ahead, maybe not print out all of the homework assignment, but maybe just the homework assignment for today, what you can do is I'm going to go ahead and attach this to the assignment so that way you guys have it for week 2 Monday. Let's go ahead and delete that. There are only 4 pages that you need today. Here's page 1, page 2, page 3, and page 4. And I'll go ahead and save this as a PDF so that way you have access to this, even if you don't have MS Word or MS PowerPoint. Week 2, Monday, CalcAB semester 2, integration and definite integral. Okay, this needs to be moved. And I want to put in guided notes. And then we'll just save it as a PDF. Awesome. So let's go back to MS Team so that way I can go ahead and attach this to it. And there's your week 2 assignment. And let's go ahead and attach this. And there we go. Okay, so now let's get together, or get started with what we're doing today. Okay, so you have three different sheets. Actually, I should say 4 different sheets. Let's start with this one right here. Actually, no, I'm not going to start with that one. I'm going to start with this one. Today, we're going to talk about definite integrals. It's just one question that I would like to show you guys. You can actually write this anywhere, or you could just simply pay attention. If you take a look at this question right here, what do you notice as a big difference between this one and the previous examples that we've gone over from week 1? And the one thing that you should say is that there's the bounds, right? The lower bound and the upper bounds. And so what this means is that you're essentially looking for the area of this polynomial. And if this polynomial, let's say, looks like something like this, okay, I'm just gonna briefly draw it, something like this, which it doesn't, but I'm just gonna say it does. What you're asking to do with integral, because integration is finding the area under a curve, okay? So this is between 3 and 4. So 1, 2, 3, 4. You're essentially looking at the area between 3 and 4 under this blue curve, and that is the area that you're looking for and finding when it comes to definite integrals. Well, you already know how to find the integration of this, so let's just go ahead and do that. So the integral of x squared is just going to be plus 1, so that's a 3 divided by 3. Integrals of x is just 1 plus 1, which is a 2 divided by 2. And the integral of -2 is just 2x. So you have x cubed over 3 plus x squared over 2 minus 2x. And you're going to draw this line. And we're going to evaluate this integral between 3 to 4. So what does that mean exactly? What you're going to do is you're going to go ahead and plug in this 4 in place of x, and that's going to give you, let's say, some number, okay? Then you're also going to take the lower bound and plug it in here for x, and that's going to give you another number. And what you're going to do is you're going to subtract the 2, because when you go ahead and look for the first number, it is giving you the area of the integral up to all the way to the left side to 4. So it's this entire yellow region. Okay, everything from the left side up to 4. That's the area you're looking at. If you're just looking at or just plugging in the 4. Now, when you plug in the 3, which is this part right here, what ends up happening is you're finding the area of everything from the left side up to the 3. So this green area. So what happens if you subtract the entire yellow area and the green area? So you're subtracting the green area from the yellow area. Well, then that should give you just this tiny little piece, which is this blue area. And that is the area that you're trying to find. And that's why we have to subtract it. So hopefully visually that makes sense to you. But you always take the upper bound, subtract the lower bound. And that will give you the area of the specific piece identified by the integral, okay? All right, so let's go ahead and do that then. We're gonna go ahead and take the 4, plug it in there. So 4 to the 3rd power over 3 plus 4 squared over 2 minus 2 times 4. So with your calculator, you wanna make sure you have this in like just one number. So 4 times 4 is 16 times 4 is gonna give me a 64 over 3. 4 times 4 is 16 over 2 minus 8. Well, 64 divided by 3 is going to give me not a whole number. So let's just do 64 over 3. Okay, hold on a second. My PowerPoint's running out of space. So that's going to give me a 64 over 3 minus, this is going to be an 8. So 8 minus 8 is just going to be a 0. So the entire thing is just 64 over 3. That's the area of this yellow region from the left side all the way to 4. So then what we're going to do is we're going to go ahead and plug in the 3. And that's going to be the lower bound. So everything up here is the upper bound. So the lower bound is going to be with 3. So I have 3 cubed over 3 plus 3 squared over 2 minus 2 times 3. So that's a 27 over 3 plus a 9 over 2 minus a 6, which is a 9 because it's 9 over 2 minus 6. Well, 9 minus 6 is going to give me a 3. So that's a 9 over 2 minus a 3. I want to have a common denominator. So if I move that a 2, this becomes a 6, which is going to give me a 3 over 2. So my area that is up to the 3 is just a 3 over 2. Now, that number looked really small, so I just want to make sure I'm doing this correctly in case if I made a whoops somewhere. Hold on a second, let me just make sure. And I did make a mistake somewhere. So where's my mistake? I don't see it. Oh, wait, hold on. Oh, here we go. See, I knew this number was a little bit small. You see, I put 9 minus 6 is a positive 3. I put a minus 3, so that's where the problem is. So sorry about that. So plus 3 over 1. So if I change that to a common denominator, that becomes a 2, that becomes a 6, 15 over 2, or 7.5. Okay, so that is the correct answer. Now what I need to do is I need to take my area of the upper bound and my area of the lower bound, and I want to subtract the 2. So upper bound minus lower bound. So 64 over 3 minus 15 over 2. And if you want to keep it in a decimal, that'll be a 6. Times by 2 is 128. 6 times by 3, that's a 45. So then 128 minus 45 should give you a 83 over 6. And that's as far as you goes. And that's your answer right there. That's how you find the area of the definite integrals. And this is this area right here. So whatever it's going to be, it's my unit squared for area. All right, you guys, let's go ahead and start over here. So I'm going to go over several questions with you guys. You have 16 different boxes, and you're just going to go ahead and give yourself 1 point if you get it right. And even if you didn't get it right, you can go ahead and correct it and just give yourself the point back. So we're going to do some whiteboard practice. If you're in class, you'll have a whiteboard, but because you're at home, you're going to be writing this anywhere that you will like with, pencil, paper, dry erase marker. I sometimes have my kids at home write it on the marble slab counter space with a dry erase marker, and they always leave a really ugly residue, but that's okay. All right, so let's go ahead and get started. Let's just jump right in. First question, here we go. What is the integral of negative 4 over x cubed minus 8 over x to the 5th power? You can go ahead and pause the video, go ahead and do the question. You can write this on box number 1. Okay, so I'm just going to go over this with you. If you move that up, you have a negative 4x to the 3rd, or negative 3rd, minus 8x to the negative 5th, and we're going to find the integral of this. So we're going to start off easy. Plus 1 gives me a negative 2 divided by negative 2, which is going to give you a positive 2x to the negative 2nd power, which I can go ahead and put 2 over x squared. Same thing on the second part. Plus the 1 gives me a negative 4 divided by the negative 4, and I have a positive 2x to the negative 4th power. You want to bring that down, so plus 2 over x to the 4th power plus c, and that is your answer. Okay, question number 2. Go ahead and pause the video and give that a try. All right, I'm just going to jump right into it. So integral of negative 5, I don't like radicals, so I'm going to put x to the 1/4. Put the 2 with this one. Again, you're going to add a 1. So if I add a 1, it's a 4 over 4, which makes it a 5 over 4. And then I have to divide this entire thing by a 5/4. Now keep in mind when you do this, you have to go ahead and flip this. So you will have a -5/2 times 4/5 after you flip it, and you have x to the 5/4. The 5's cancel. 4 divided by 2 is a -2, x to the 5/4. Or if you go ahead and rewrite it back into a radical form, -2 fourth root of x to the 5th power. Although if you want to be fancy about it and you actually simplify this even further, you know you could take out an x because you need 4 of a kind of x and you have 5, but you have 1x remaining on the inside. And this is your answer. So on the multiple choice question in your AP exam, you just don't know which one they'll have, and so it's really important that you know how to manipulate your algebraic equations back and forth. All right, this is going to be question number 3. This is a little bit of a tricky one, mainly because if you look at this right here, if I add the 1, it gives me a 0. And I know some of you guys are like, oh, it's x is 0, which is 1. So 1 times 3 is just going to be 3. No. And the reason for that is because you can't divide the entire thing by 0 because it gives you an undefined. So at this point, there is a new formula, and it is the integral of 1/x. We haven't talked about it yet, but we will get there. But today, just kind of surfaces to this. Integral of 1/x is always going to be ln x plus c. So what you can do with this is because the 3 is a constant, you can move it over to the left like this. Rewrite x to the -1 as 1/x dx. And so the integral of 1/x is just ln x. So your answer is 3 ln x plus c. And we will talk about ln x a lot more. Does it get more difficult than this? Absolutely. This is just a brief little intro. All right, so this is question number 4. Go ahead and FOIL it and then integrate this. Pause the video, give it a try on your own. All right, so as I'm looking at this, I will FOIL this. And actually, you know what? I'm not going to go over it because we've gone over plenty of questions like this. Here is the answer, and here's my steps if you need it. I'm going to kind of jump into the more difficult ones. All right, question number, I think it's number 5. Number 5. All right, with this one, what we're going to do is you want to separate the fractions. So you have x over square root of x, or x over x to the 1/2, plus 1 over x to the 1/2. You want to combine these two x's into 1, so that way I can integrate it. So if this is a 1/1, if I move that one up, it's going to be that minus 1/2, which is a 2/2 minus that, which is a 1/2. So I have the integral of x to the 1/2. Plus move this one up, x to the -1/2. Let's go ahead and integrate this. Plus 2/2 gives me a 3/2 divided by 3/2. Flip the denominator to 2/3 x to the 3/2. Plus, let's go ahead and integrate the second piece here, plus 2/2, which is a 1/2, divided by 1/2. Flip that, 2/1, which is just a 2, x to the 1/2 plus c. Okay, so I'm going to skip this one because that one's just like the last one with a FOIL. Let's go ahead and do this one, number 6. Go ahead and pause the video and give it a try. Okay, so I see a fraction and a radical, which I don't like either of them. So I'm going to change that radical form into exponential form. And then remember, this is a 2/2, so you're going to add them together, combine into one x value, which is a 3/2. Bring it up. So you have an x then -3/2, and integrate that. Plus a 1, which is a 2/2, gives me a -1/2. Divided by a -1/2, flip that. X to the -1/2 Rewrite it so you don't have a negative exponent. Bring it down to the denominator. You have x to the positive 1/2, or just square root of x plus c, which is exactly what I have right here. All right, let's kind of jump into some of the more difficult questions. I feel like we kind of had enough of this, so let's take a look at something that looks like this. So this is number, shoot, I forgot what number it is, 6 or 7. Okay, I'm just gonna put 7. I don't know what number it is. I kind of lost count. So number 7, sorry. If it's number 6, I apologize. Okay, it says solve for y prime equals 3x minus 4, and the point 410 is on the graph of y. You want to find y equals mx plus b. So we're kind of going to be working backwards. So pause the video and give that a try. All right, so we have, remember back in semester 1, I told you guys there are different ways of writing derivative. First way you could do is y prime, another way is f prime of x. Ooh, this pen is going a little weird, crazy. Okay, and oh my goodness, derivative. And another way of writing f prime of x is dy over dx. Okay, so I'm going to rewrite this as dy over dx equals 3x minus 4. Now, if I'm looking at the derivative of this, when I'm doing the reverse of the derivative, which is going to be the integral, I want the x's to be by its side on the same side. So then I'm going to have dy is equal to 3x minus 4. Move the dx over, so dx. So then I'm going to go ahead and do the integration of both sides. The integral of dy is just going to give me y. So I have the y already. Then I need to take a look at this. 1 plus a 1 is a 2 divided by 2. So integral of 3x is going to be 3 over 2x squared. Do the same thing with a negative 4. Integral of negative 4 is a negative 4x plus c. Well, I want to know what my c value is. And lucky for you, you're provided with a point. Now this point is going to be for x and y. So my y is 10. My x is 4. 4 times 4 plus c. So 3 over 2 times 16 minus 16 plus c. And I know the 16 divided by 2 gives me an 8. 8 times 3 is going to give me a, 24 minus 16 plus c. 16 minus 16, or 24 minus 16 is going to give me an 8. So then just by solving for c, c equals 2. So then what I'm going to do with that 2 is I'm going to take that 2 and I'm going to go ahead and plug it back into this equation right here. So my final equation is y equals 3 over 2x squared minus 4x plus 2. And this is your answer. Okay, let's jump into number 8. Pause the video. Notice that this one you have a double prime. So you're going to have to integrate this twice to get to y. Okay, so let's work backwards. So we're going to do this. We're going to do the integral of f double prime of x, which is equal to the integral of 6x plus 4. Well, the integral of double prime of x is going to be f prime of x. Integral of 6x is going to be a 6 divided by 2, which is 3x squared. Integral of 4 is just 4x plus c. And because this is in the form of f prime of x, it's given to you that f prime of x, or f prime of 0, is equal to 3. So from here, you know that when x equals 0, y is equal to 3. So I'm going to take that hint and plug it in here. So f prime of 0 is equal to 3 times 0 plus 4 times 0 plus c, which is equal to 3. Well, this one's pretty simple because the 0 just cancels out and c equals 3. So I'm going to go ahead and rewrite my new f prime of x with the new information that I just found. 3x squared plus 4x plus 3. Ultimately, my goal is to find f of x. So what that means is I have to integrate this one more time. Integral f prime of x is just f of x. So then the integral of 3x squared is just going to be x cubed. Integral of 4x is just going to be 2x squared. And the integral of 3 is just 3x plus c. And as you can see from here, it is given to you another hint that f of 1 is equal to 5. So what that means is when x is equal to 1, y is equal to 5, and I'm going to plug that into this new equation here to solve for c. So I'm going to do f of 1 is equal to 1 cubed plus 2 times 1 squared plus 3 times 1 plus c. And so what that means is I have just 1 plus 2 plus 3 plus c. And remember, this is equal to 5. So let's add everything together. That's 6 plus c equals 5. So c equals -1. And there you have it. This is your finalized answer. F of x is equal to, because you're going to take this -1, plug it right here back for c, is x cubed plus 2x squared plus 3x minus 1. And that is your answer. All right, you guys, for number 8, go ahead, or maybe it's number 9. I'm sorry, I'm losing count. I think it's number 9. Go ahead and pause the video and answer the following question. Sorry. Okay, so here is my steps to the answer. And I know you're like, okay, so why do they put a K and a C? Because when you're doing two different integrals, like the first one and the second one, sometimes people get confused because you have like two C's. So sometimes they'll put a C1 or C2, or sometimes they use a K for the constant, just so you can distinguish the difference between the first integral to the second integral, etc. All right, so at this point, we have gone over several examples. If you would like some additional practice, go on to this page right here, which is page 2, page 3, and page 4, and you do have some additional practices that you guys can do. All right, I hope you have a wonderful week. As always, stay safe and healthy. Tomorrow, I will update your grade with the Math Excel and also the AP College Board from Wednesday, and also the Math Excel from week 1 that's due on Sunday. And I'll see you guys next time. Take care.